we go. We need to do 20 questions. So number one, Q by T is Ka delta T by delta X, conductivity. You got to find T. Make T the subject. You get Q by Ka del X by delta T. And I'm trying to show that the delta X will go to the top, isn't it? Then substitute the numbers. Q is a million. And why is it 0.003? You divide by 100, it becomes 0.003 meter. And down there you have K. Take a look at K, please. Isn't it in kilocalories? Change it into calories. What do? Multiply by 1,000. No, kilo. To change into calories, you multiply by 1,000. So that will become 2 times, what? 10 to the negative 4 times 1,000. Did you see that? Do you see what I did? And then you have your temperature difference, which is, what's the temperature difference? 10 degrees Celsius? Yeah. Okay, and it's 750 seconds, which is 12.5 minutes. Well, I'm trying to explain that kilocalorie to change into calorie multiply by 1,000. So the answer is 12.5 minutes. Great. All right, 100 miles require 100 miles divided by 25 miles per gallon, which gave you 4 gallons. 1 gallon is 3.8 liters. Therefore, 4 gallons would be 4 times 3.8, 15.2 liters. The density of gasoline is the same as that of water, which is 1,000 kilogram per meter cube. I don't know why I had to write that, which is the same as 1 kilogram per liter, okay? And then density is mass by volume. Mass is density times volume. So 1,000 times 15.2 times 10 to the negative 3. Why did I do that? Because the volume given is in liters, I have to change it to meter cube. See, when I told you, I give it to you in an easier way. See, 1,000 times 10 to the negative 3 is 1, isn't it? That's what it's 1. Just take it as 1 kilogram per liter, you get the same thing. 15.2 kilograms. So the energy that you need is 15.2 times that big number, 4.8 times 10 to the 7. And your answer is 7.3. It's 10 to the 8 joules. Oh, I don't know. Sometimes I put H as the symbol for quantity of heat. Please, H is your Q, okay? Q is mc delta T. You're asked to find C. And C is Q by m delta T. Okay, now I'm showing how to change Fahrenheit difference into Celsius. Is that what you got? 222.2? Okay, now put it into that, and that's your answer. Q divided by mc delta T. I mean m delta T.
Excuse me, can you explain again why you got 1 by 8? No.
Number 4, heat. That means the heat required to take it from 53 to 328. Again, I'm writing H, but it's Q, okay? Oh, it's 23. I wrote it as 53. I don't know where I got it from. Anyway, I'm going to continue with that. I'm so sorry. You write it as 23. So 426.3 joules. What happened? Now I changed it to 23. Okay. 472.75 joules. So heat to melt lead. Q is m times the latent heat. Why did I use 5900? What is given?
Oh, kilocalories.
It's kilocalories, so I put it as 5900. And then total heat, you add both. Add both of those. Well, I have to correct that, yes. you get 768 calories. Yeah, I think. All right, number 5, H is, or Q is M times the latent heat, 0.2 times 80,000. You know that 80 kilocalories is 80,000 calories, that's why. And the answer is 1.6 times 10 to the 4, which is 16 times 10 to the 3, and therefore it's 16 kilojoules. Be careful about that. 16 kilojoules. Done? Number 6. First you use Q or H is mc delta T to heat it from 0 degrees Celsius to 100 degrees Celsius. Why 100? Because that's the boiling point of water. And put in the numbers, 2 times 1,000. Where did I get the 1,000 from? It'll be given to you. The specific heat of water is 1,000 calories per kilogram. Didn't I tell you that's 1 kilocalorie per kilo? That's it. 1,000 calories per kilogram, so that'll be given. And then find the heat required to vaporize it or to boil off, which is again the same mass. And the latent heat will be given to you. Did anybody remember that? It's 540 kilocalories in that graph that we were studying? Nobody? Okay, 540,000. That'll again be given. Add them up to get the total heat. And this will be 12.8 times 10 to the 5. Be careful when you add that. Yeah, somebody asked me, so I was saying this is common, isn't it? That's why you take these two and just add. Get that as the answer. Watch this. Heat lost by the hot is equal to the heat gained by the cold. That's what you use as a formula. And for both, the formula is mc delta T. Hold on a second. Where did I get that 3C from? It says the hot object has 3 times the specific heat as the cold, isn't it? And the mass not given, I took it as m. And where did I get the 100 minus x?
This is the initial temperature.
Was 100, and we do not know to what it went, isn't it? So we take it as x. Are you with me? 100 minus x. All right. Is equal to, okay, m times c times x minus 0. Why? X minus 0. You always take the bigger temperature minus the smaller, okay? The initial was 0, and the final is going to be x. So you take x minus 0. Now it's easy. What do? Cancel the masses. Cancel the c's. So you got 300 minus 3x is equal to x. Take that negative 3x to the other side, will become 4x. And then divide. So x is 300 by 4, which is 75 degrees Celsius. Problem done. All right, number 8. mc delta T. You have to find the change in temperature, so make that the subject. And then 40 kilocalories is 40,000 calories divided by the mass is 2 times the specific heat of water is 1,000. So I can't fill those thousands. I got 40 divided by 2, 20 degrees Celsius. Here it is, number 9. That's conduction. So Q is Ka delta T by delta X. And you got, first find delta T. Although you're not asked to find delta T, first find it. Delta T is Q delta X by Ka. And 4,000 kilocalories is 4,000 times 10 to the 3. And X is in centimeters. That's why divided by 100 became meters. K is also given in kilocalories. So, and I forgot to put T there. I added T now. Did you notice that? You see the time? I forgot that time thing altogether. Then time. Why is it 3600?
As a time.
Yeah, it said 1 hour, and 1 hour is 3600 seconds. So I'm showing how you get that 0.2. 2 times 10 to the negative 4 times 10 to the 3. When you change kilokelvins, which is 0.2 actually. That's why I put it as 0.2. 1 hour is 3600 seconds. Okay. You got the difference in temperature, but you're asked to find the temperature outside, isn't it? So you have to put it that way. 20 minus T is that, and you get the answers 15.83. How do I know that the outside temperature is less? What does the problem say? Are you gaining heat or losing heat? So is it summer or winter? Yeah. That's why I know that the outside temperature is less than the inside temperature. All right, number 12. What? Sorry.
Thanks for giving the answer.
All right, number 11 now. 200 liter is 200 kilograms. Anybody remembers that? Yeah, it's only for water, please. 1 liter is 1 kilogram. H is mc delta T. 200 kilograms times aha. That's the problem. Now the specific heat of water must be given in joules per kilogram. Do you see that? And that will be given to, don't you worry, 4,186 or 4,185 will be given to you. That's the specific heat of water in joule per kilogram per Kelvin. So some are saying, man, change in temperature 75, 23. All right, so you need that many joules, 43 million joules. And then the heater supplies 2 kilowatts, which is 2,000 watts, and that is 2,000 joules in a second. The heat supplied in T seconds would be 2,000 times T. Hold on. Heater supplies 2,000 joules per second. What does that mean? Means every second it gives you 2,000 joules, isn't it? That's why the next step I said, therefore the heat in T seconds would be 2,000 multiplied by T. And I'm going to set that equal to that much. Finished. So 2,000 times T is equal to 4.352 times 10 to the 7. So T is, or you could have just divided that if you could work it out in your head. Divide that and you get it. 2.176 times 10 to the 4 seconds. You got to change it into hours. Divide by 3,600. And you get it as what? 6.045 hours, approximately 6 hours. With that, you should be able to understand. Number 12. Well, I put it as E by T, which is the same as your Q by T. Going crazy sometimes. What is E1? It's black body. Sigma is a constant. It's 5.67 times 10 to the negative 8. It will come up now. I put the more accurate one. 5.669 times 10 to the negative 8. A is the area. Area is in centimeters squared. Did you notice? How do you change into meter squared?
Divided by 100 by 100.
Yeah, 100 by 100. So that's why it's 10 to the negative 4. And I'm changing it into Kelvin by adding 273 and raised to 4. Isn't it? And you should get 38.76. Anybody got it? No, nobody calculated. Matthew, you got it? Did you calculate? Because you really have to be careful on this calculation because the last one is raised to 4. Look, it's not times 10 to the 4. Do you notice? That means you have to multiply that number 4 times. Isn't that what it means? Okay. How did I get? That's a constant, Marina. It's called Stephen's constant. Oh my. Okay. I heat in the metal. MC delta T. Mass 80 grams. Yeah, and specific heat is given in calories per gram, so I'm trying to show that. See, it's okay. The units are fine, right? Trying to show you that you get it in calories, and then you look at the heat gained by water. Again, the same formula. You're looking for the mass of water, so you do not know. Well, I set them equal already. You can see that, right? 3344 is equal to m times 1, because that's the specific heat of water in calories per gram. 1 gram. What?
You erased because you didn't need what?
Oh, I did it with 400. But you understood, right? It was 400 minus 100. Are you with me? It was 400 minus 100. Probably I realized after I wrote it. 400 minus 100. 300. That's why it's, the number changed to 2640 divided by 80, 33 grams. That's why you should not write with me. All right, here we go. Number 14. You see two metals there. For those of you who read the question, aluminum and brass, right? And did the question say that the lengths are the same? And the areas are the same? They join together end to end. Okay. The free ends are at 0 and 200. Is that correct? And you've got to find what? The temperature in the middle there where they meet. Uh-oh. Okay, what's my idea? Something that I wrote didn't come up. What's the idea that you use here? You almost got it, because half of it is written. Which is a better conductor? Aluminum or brass? Aluminum. So, you know, when you connect two pipes together, even if one is big, the other is small, the volume of water that flows through both should be the same. You remember that? That's why the speed of flow in the smaller one would be faster. Correct? Same thing. So the heat conducted by aluminum would be equal to the heat conducted by brass, because heat cannot get stagnant there in the middle. Now it has to go through. Okay? That's the idea. That's why I'm trying to put two together. On the left side I have heat conducted by aluminum. On the right side I have heat conducted by brass. So now you can write it. You can write 2K times, what's the formula for conduction? Isn't it Ka dt by, or delta T by delta X, or whatever, right? That's what I'm writing. The lengths get cancelled. Well, I might write it later on, and you will see. Everything gets cancelled there, K's and the lengths and the area. Okay, now I wrote it. Now the picture is complete. You know why I got 200 minus X? Sure. 200 minus X. And the second one is X minus 0. Easy. And you get 400 by 3, of course, 133 degree Celsius. Yeah, now I'm writing Q by T for aluminum is equal to Q by T for brass, just to give you that idea. There are three processes here. Number one, water at 50 degrees Celsius has to be heated to 100. Formula, MC delta T. Mass is going to be the same, 10 kilograms. That's the specific heat, 4186, and change in temperature. You get that as the quantity of heat. Now the second process, heat required to boil water to steam at 100. Remember the formula is mass times latent heat now. 10 times. That is the latent heat in proper units, joule per kilogram. So don't ask me where I got it from. That's the latent heat. It will be given to you. Now, heat required to take steam from 100 to 120. Again, it's normal heating. Now you need the specific heat of steam, which is 2017. Okay. And finally, you add up all the three. Big numbers, isn't it? Be careful. You need that much. 2.5 times 10 to the 7 joules for the entire process. And you should have noticed that more energy was required for boiling water to steam. Did you notice? Because that's the biggest number. We are on in question 16. It's about conduction, and you have to find the quantity of heat in 1 second, because it says the rate of heat conduction. So go ahead, put the conductivity of glass, which will be given as 0.8372, and the area is length times width, 3 times 1.5. Take note that the difference in temperature is 20, take away -10, and then divide by the thickness, which is 0.005 when you change it into meter. Get it as 22604.4 watts, which is 22.6 kilowatts. In 17, the machine is made of 2 parts, iron and copper, so you got to separately calculate the quantity of heat required for each one and then add them up. So quantity for iron is mass of that times its specific heat times the change in temperature, which is 35 Celsius. Do you know that the change in temperature will be the same in Celsius or Kelvin, so get 1575 joules. Do the same thing for copper using the same formula, and the mass is 0.16 now, and its specific heat is given 390 times the same change in temperature, get 2184. Define the total heat, add them up. You get 1575 plus 2184 is 3759 joules. In 18, you just have to convert kilocalories into joules. And first convert into calorie, because 1 kilocalorie is 1,000, multiply by 1,000. And then remember that 1 calorie is 4.186 joules, so 16,500 calories would be that multiplied by 4.186. Get as 69,069 joules, which is about 69,100 joules. 19, at what rate is the human body radiating energy? And so that's Q by T that you have to find. At what rate? So it's Q by T. Again, E is 1 for a black body. Sigma is Stephan's constant. It's 10 to the -8, not 10 to the -9. It's going to be 10 to the -8. And then times area times temperature must be in Kelvin, so that's why you got 273 plus. Alright, so that's 10 to the -8 now, and then when you calculate, you get 695.9 watts, which is approximately 700 watts. So that's the amount of heat lost in 1 second from the human body. And on 20, it's not 10, it's 20. It's the same question as 16. The only difference is you have to find the heat that is lost in 1 hour. And in 16, we found the heat lost in 1 second as 22.6 kilowatts. So just multiply that with 3600, and you get the total heat lost in 1 hour, which is 81,360 kilojoules. And since the answer is in mega, remember 1000 kilojoules is 1 megajoule, and so you get 81.36 megajoules. Thank you and good luck.